Welcome to Effective Refrigerant Recovery Techniques, Overview and Step-by-Step Instructions. With the largest single line of top-quality durable HVAC and R tools in the industry, Yellow Jacket is a name professionals like you all over the world have come to trust. With this DVD, we now offer you the instruction and straightforward how-to knowledge to go along with the tools. We hope you'll find this guide beneficial to both you and your business. Now, let's get started. One of the most common tasks in maintaining or repairing HVAC systems is refrigerant recovery. Understanding the different recovery methods will help you be more efficient. Plus, when you follow the proper procedures for each of the methods, you'll prevent harm to both you and the equipment while getting the job done right the first time. Before we begin, let's talk briefly about safety. One of the most important aspects of safety and recovery is having the right equipment and understanding which type of refrigerant you're recovering. For example, if you're working with R410A, you're working with significantly higher pressures than if you're working with R22. This means you may need different equipment made to handle the higher pressures associated with R410A. So, what equipment will you need? First, you'll need a good pair of safety goggles, like these from Yellow Jacket, and a good set of gloves to prevent frostbite. Most technicians use a manifold set, like this Yellow Jacket 4-valve Titan with 2 center utility ports, 1/4 inch for recovery and 3/8 inch for vacuum, in addition to the blue and red low and high side ports. Make sure the manifold gauges are rated for the refrigerant pressure you're working with. You'll also need a set of hoses. We're using 1/4 inch Yellow Jacket Plus 2 charging hoses. For best performance, however, we recommend 3/8 inch hoses. It's important to ensure both the hoses and the assemblies are UL recognized. And be sure to check the condition of your hoses prior to use. It's best if you can use the shortest hoses possible for a given job, making for more efficient recovery and reducing the impact on the environment. Obviously, you'll also need a recovery unit, like our Yellow Jacket Recover XLT. This unit is built with all of the features you'll want your recovery unit to have, including a large condenser, oversized fan, compressor protection regulator or CPR valve, and a high-pressure cutout switch rated for at least 510 psi. Some manufacturers offer a subcooling feature, which is an excellent way to increase your rate of recovery in high ambient conditions. Finally, you'll need the appropriate recovery tank. Now, when recovering R410A, you need to use a US DOT 400 recovery tank. Why? Well, a standard DOT 350 will not safely handle the high pressures of R410A. So be sure you have the right tank for the job and that you do not fill it beyond 80% capacity, a DOT regulation. Another DOT regulation requires a recertification of the tank every 5 years. So be sure to check the date on your tank to see if a recertification is due. When recovering refrigerant, there are 3 basic methods: liquid, vapor, and push-pull. Let's talk briefly about when you would use each method, and then we'll walk through each of them step by step. In the liquid recovery method, you are able to transfer refrigerant while still in the liquid state. This method is especially good for transferring refrigerant from one container to another. Of the 3 recovery methods, liquid recovery is the fastest. So, why wouldn't you use it? Because it's simply not possible with all HVAC systems. In those cases, you'll have to use the vapor recovery method. Vapor recovery is slower than liquid recovery, but also the most common method. It simply transfers the refrigerant in the vapor state. The process for liquid recovery and vapor recovery are very similar. The only differences are the state of the refrigerant and some unit settings. Finally, there's the push-pull method of recovery. Push-pull quickly removes liquid refrigerant, but it's a 2-step process. Once all the liquid is removed in the first step, you have to change hose connections to recover the vapor. Generally speaking, you'd only use the push-pull method if you have more than 10 pounds of refrigerant in the system. Push-pull is not recommended if the system is a heat pump or is one with a reversing valve. nor would you use it if the system won't allow a solid column of liquid to form, or if the system has an accumulator. In the liquid recovery method, refrigerant is transferred while still in the liquid state. Let's walk through the process. When you're ready to start, make sure the system you're servicing is turned off. Also check that the recovery machine selector knob is set to off and all valves on the manifold are closed. We're using a manifold for this demonstration because it has additional metering and allows us to pull from both the high and low side ports at the same time. Now, connect your manifold to the system being serviced, high side to liquid port and low side to vapor port. Now, connect a 1/4-inch utility hose of your manifold to the suction port of the recovery machine. Finally, connect a hose from the liquid side of the recovery cylinder to the discharge port. You'll want to be sure that the ends with the shutoffs are used at the suction and discharge ports. This is required by law. We're using 1/4-inch hoses, like these Yellow Jacket +2 hoses. When you're done making all connections, your setup should look something like this. Before beginning the recovery, purge all hoses of non-condensables. Now, open the liquid valve on the recovery tank. When using the Recover XLT model as shown, you'll need to zero out the scale and monitor it to avoid overfilling. DOT regulations mandate that tanks cannot be filled beyond 80% capacity. You're now ready to turn the recovery unit on. Next, turn the selector valve on the recovery unit to liquid. Open the high side valve and the utility port on the manifold. The unit will recover until the low pressure switch shuts down the unit and the lamp indicates recovery complete. This is an important feature of the Yellow Jacket Recover XLT recovery units. When the pressure in the system reaches the proper vacuum, which varies depending on the type and size of the equipment, the machine simply shuts off automatically. If the pressure were to rise again, the machine would then turn itself back on. This process will continue until the appropriate vacuum level is maintained. Now you can turn the system switch off and turn the selector valve clockwise to off. Now, as you know, you need to purge the recovery system next. Purging clears the recovery unit of refrigerant, reducing the risk of cross-contamination and prolonging the life of your equipment. Because of this, you must purge your unit after every service. The good news is that the Yellow Jacket Recover XLT has an auto purge feature. Here's how it works. You turn the system switch on, and then you turn the selector valve to the purge position. Both the high and low side gauges will equalize and begin to drop into a vacuum. This lets you know that the purge process is working. When the unit again shuts down and the lamp indicates recovery complete, then your liquid recovery process is complete. And those are the basics of liquid recovery. In vapor recovery, we remove the refrigerant from the HVAC system in a vapor state. Then the vapor is condensed into a liquid by the recovery unit and finally transferred to the recovery cylinder. Here's the basic process. When you're ready to start, make sure that the system you're servicing is powered off. Then check that the recovery machine selector knob is also set to off and all valves on the manifold are closed. For this demonstration, we're using a manifold to monitor pressure, as it provides a metering option and allows us to pull from both the high and low side ports at the same time.